is not happening unless they.
Hello, class. Hello, class. Nobody.
Morning, sir.
All right, I got some kind of feedback. All right, how y'all doing?
Doing all right.
All right. Everybody took my test and everything? Hello?
Yes, sir.
All right. Okay. Now, before we get started, we got like one more week left, right? If I pull this up, we got next week, and then the next week is Thanksgiving, correct? Well, we got a one day, right? And then
Right.
wait a minute. No, next week is Thanksgiving, right? But we have that one day before Thanksgiving because I normally, and I didn't look at the holiday schedule, but normally the holiday schedule starts on Wednesday, Thursday, and we off those 2 days. Um, Next week I'm gonna open up the makeups. Everybody hear me? Hey, put your name in the chat for the role. But next week I'm gonna open up the practice final and the makeups. Everybody got that?
Yes, sir.
All right. Now the makeup, you are allowed to make up tests and quizzes. All right. So all the tests and quizzes that we've taken, I'll give one extra opportunity. Now, what happens is some people who have taken the two opportunities already will get that one opportunity. Those who've never taken it at all will have the three opportunities. And those who may have taken it once will have two remaining opportunities. All right. But like I say, make sure you take advantage of this. Don't come to the end of the semester. Oh, Mr. Sylvester, I couldn't, I didn't, or whatever. It's going to be open I could open it from Sunday. I could open them all from Sunday to Sunday. All right. Well, let's see. Yeah, because finals gonna start on the 30th, and I'll do the final. The final exam will be open from the 30th through the 4th. All right. Now, another thing I'm gonna open is an assessment, and it'll be under the finals module. On the modules, go to final. You'll see CSCI 194 assessment. All the assessment is it's questions based on topics that we feel you should have understood or grasped while taking this course. All right. So what we will be doing was looking at that to assess to see how much of that did you understand. All right. So do the assessment. All right. I want you to do the assessment. You're gonna have your practice final, and then the final will be posted from the 30th through the 4th. Okay. So you got from Monday to Friday to take the final. But you have from I'm gonna make the 22nd which is a Sunday, through the 29th, which is a Sunday, to do your practice final. The practice final, what happens is it'll grab 50, I think it's 18 questions, all right, from the different chapters, and you take it. It's gonna score it. It won't tell you what you missed, but you, based on the question, can go back, look through the chapter, and say, okay, well, this was a question. Oh, I answered this, this is that. So it doesn't give you the answer, but it gives you an opportunity to go back and look to see if you answered all what you answered correctly. And you take it, and some people, what they do, they choose not to take it at all. All right. Some people take it and they one time and say, oh man, I made a good grade, I'm ready. That's not necessarily true because you've only seen 18 questions. The more time you take it, as the more questions you'll see. So, like I say, if I was you, I would take it as many times as you can and try to do your best on each opportunity. And even if you got issues or with a question, go back and review that question or look it up in the book to make sure you can find the answer. All right. Anybody have any questions?
Yeah, Mr. Sylvester.
Ms. Bradford,
Hey,
how you doing?
good. November 30th. What did you say for November 30th? You're gonna do what? Open the final?
The final, yeah. See, I'm treating it like an online class, and like I say, we got the cameras and whatever when you go into the proctorial. So from the 30th through the 4th, like I said, you're gonna have two opportunities. So what you can do is say, okay, I'm gonna take the test on Monday. You take it on Monday, and you say, well, I made a fair grade, but I'm gonna go back and do some studying through my chapter, and then you can take the second chance on maybe Thursday. With Thanksgiving, you might not want to, or either that Friday. You understand? But
Yeah.
it's up to you, or you could take them back to back. Up to you. But I'll give you that option from the 30th through the 4th. Not say, okay, on Tuesday at 2 o'clock to 4 o'clock, take your test. And then some people might, well, Mr. Vest, I'm going out of town. We'll be driving, so I eliminate a lot of those different things, where you can find one day out of those 5 days where you can have your peace, you're quiet, sit down, take your test, and hopefully you can do a good job on the test. All right.
Okay, and you said for the other ones, like the different programs, you're gonna open that up as well?
Well, not programs.
Oh, okay.
Tests and quizzes.
Okay.
Yeah, tests and quizzes. You trying to kill me now?
Well, so you're not gonna open up the ones that we did ban on?
Because what happened now, this is what happens. What happened is I'd have to play checkerboard with the grade book. Oh, this person turned this in. This person turned this one in. Oh, this one turned that. So I'd have to be scattered through all the grade book trying to find out who submitted something and where and getting it right. So it's just too much on me.
Okay.
You know what I'm saying? Yeah, to do that. Yeah. That's why I asked you to try to do your work, on time, at least the work itself, so we could get that big portion out the way.
Okay.
Yeah. Right. Any other questions? Now, I want you to remember, and class, how would I say it? Well, I'm going to just say, we know that what? our test is worth 30% of our grade, right?
Yeah.
But the final is worth 20% of our grade. If you look, and I've graded all of the assignments and whatever for you, and say you are at a, say your grade is at a 65, okay? Just example. Your grade is at a 65, but you haven't taken the final yet. If you make a 50 on the final, that means 10 points is added to that percentage point, which would make you have a what? What would make your grade a what? A
75?
75. Everybody understand that? Hello?
Yes, sir.
All right. Everybody understand? So, so when you look at your final grade, when you go to take your final, you might be at a 90, or say you're at an 85 and you make a 50. That 85 becomes what? Close to the 75, because that's 10 points. Half of 20, right? Half of 100 is well, it says 50, but the 50 is just only 10 points added to your average, which would be from that 85 a 95. But if you make close to 100, then that's what? 20 points that's gonna boost up your grade. Everybody understand that?
Yeah, so that's why I don't see why you can't open up the program so it can make it higher.
Oh no.
Sucks.
Because I give you 2 opportunities on the test, and all that. And like I say, most times I open up the assignments 2 weeks ahead of time. Not always, but most times, and let you look at it. Then we go over it. Then I assign it, and then you have to do it. So it's just too much.
All right.
Yeah. All right. So let me share my screen. Any other questions, and we'll get on with the next chapter. All right. Questions?
Sure.
All right. Okay. So let me get to let me share my screen. Let me get here. All right. All right. So everybody can see my screen, right?
Yes, sir.
All right. So the next chapter is file operations. So now, remember we wrote at the beginning, I think it's at the beginning of the class. I think no, we did a raise, but we've already did a program where we read data from a data file, and we've written data out, to an output file. Correct? Here in this chapter, we're going to talk about some advanced file operations that allow you to write code to where you can open a file in a different way. You can open a file to append it, open a file to wipe it out and start anew, open a file for read and write, things of that nature. So with file operations, we are already familiar with these data types. The IF stream, which is for what? Input. OF stream, your output stream. And then F stream, what you can do rather than specify a data object, a file object as IF or OF stream, you can just do F stream. And when you do that, then you can do something like this. You can use the scope resolution, the iOS scope resolution, and tell it whether it's for output, whether it's to append, whether it's all of these different options. Append, the 8 with ATE, which would take it and goes directly to the end of the file. You could have a file that's written in binary. You can have it for input. You can have it for output. And then the truncate kind of works like when you do the out.
You're welcome. I do
it will automatically wipe that file out. So
the truncate one is essentially just it would truncate all the data or just
yeah, right. Yeah, will be deleted. See, look, if the file exists, all right, its contents will be what? Wiped out. So, all right, and if you, well, I don't know if you've done it. have you ever, when I gave you a program and you wrote to an output file and you use F-stream and you use OF stream. When you use OF stream, every time you ran that file, it did what to that output file? It created a new one. You understand what it didn't create? What I said, it overwrote the existing one and made it blank and put the data in. So it created that file over again. So that that's what the out does also. See, the data will be written to the file, but by default, if the file's content will be deleted if already exists. And this is somewhat using that F stream. An OF stream, the same thing happens. All right. So you got to kind of watch when you start using that, because many times you don't want to just delete all your data. You want to keep data. That's why you would use, if you want to keep data, if you already have an output file and you want to write some more data to it, you could use the what? A pin. So what happens? I have an output file sitting there, and now I want to write to it. It's going to what? It's going to continue at the bottom if I use the APP. All right. It'll open it for output, but output information toward the end. All right. All right. So let's look at the notes, see what it say. Okay. You can define a F-stream object just as you define objects of other data types. All right. So here we got F-stream data file. So we don't know if it's input or output, but it's a file what? Object. Okay. Now, it says, as with IF stream or OF stream objects, you use the F stream object's open function to open the file. So we still have to use open and then dot dot open and then in curly braces the name of the file. You still have to do that. So object open function requires two arguments. The first argument is a string containing the name of the file. And the second argument is a file access flag, and that's what we talking about when I said the iOS colon. All right, flag that indicates the mode in which you wish to open the file. So look at this. So we created a file object called data file. All right, we don't know if it's input or output at this point, but we go down here and we say data file dot open. If you look at just that part, you still don't know if it's input or output. All right, we got the file name, but when we see this flag and it says out, we are opening that file for what? Output. And that file, if it exists, will be
opened.
But if it exists, it will be deleted and then reopen, and you're going to have new data. Remember, we talked about that. See here? The data will written to the file. By default, the file content will be what? Deleted. You got what I'm saying? Right. By default. So you got to kind of understand what they do and what you want them to do. Now you can mix those up, and we'll see that later on. But now look, the first argument is the name, which is info.txt in double quotes. The second argument is the file access flag, which is what? Which is out, but iOS, the resolution, which is : out, which is the output for output, open for output. This tells C++ to open the file in output mode, which allows data to be written to the file. Now, you know where previously we just did what? OF stream data file dot open, and then the name of the file, and we finish, right? But this is just another way if you wanted to use the flags, because like I say, you could append now, you could do other stuff. All right. So here, look at this. The same object, all right, data file dot open, then you have info text, the same file name, and then iOS, and then in. So now, if you close that text file, and then you define this, now you've all of a sudden opened it for what? Input. So whatever's in that file Now it's gonna add data to it because now you opened it up for input. So say you could take a file and open it up for output. Well, no, not open it for input, mean you're reading from it. My fault. So now you could open up that file and start reading it for input. All right. So you opened it the first time and wrote to it, closed it, and then later on in your program, you opened it for input and you read the data that was recently inputted into it to do whatever you need to do with it. All right. So this statement uses the iOS in access flag to open a file in input mode, which allows data to be read from the file. And once you open a file, where's the what do you call it? Where's it start reading from?
The beginning.
Right. I think I forgot what they call it. The pointer. No, I wouldn't say pointer, but it's pointed to the first record. It'll start reading from the first record. All right. So here it tells us APP is a pin mode. If the file exists, its contents are preserved, meaning, okay, if I open a file with a pin flag and I have a list of names, and it doesn't matter what the file has in it. Everybody understand that? If I open a file for a pin, it don't matter what the file has in it. Because what? The format of the output doesn't matter on your screen. It doesn't matter in the file. It's just going to take what you give it. So I could have a list of names, 5 names, and then I append it, and then I could put a amount and a score, amount and a score, amount and a score, and then I could add other stuff to it until I close that file. So it's not like when you read in a file. When you read in a file, what? You got to read in the proper data. If I'm reading in a string, it has to be a string. If I'm reading in a float, that number has to be a number or a float. If I'm reading in an int, that number has to be an int, not a float, because it'll throw your data off. When you're outputting, you're not concerned with that. But when you're inputting, your data format has to be, correct. Then the ATA, all right? If the file exists, okay, the program goes directly to the end of it, okay? Output may be written anywhere in the file, all right? So like I say, with this one, you can kind of direct. I never really used this one. You can actually input data where you want in the file. Binary mode, it'll just write your data in binary. Also, you could read it at binary. So when a file is open in binary, the data are written to or read from in a pure binary format. Okay. All right. The default mode is text unless you tell it what binary. N, we know N is for input mode. Data will be read from the file. All right. If the file does not exist, normally you would get an error, remember? Or you could have that fail flag in there. Remember what those in I think it was chapter 5 in the book, you could have where you could check to see if the file exists. If it doesn't exist, then you're gonna throw out an error message. But if it does exist, then you can go and continue to read data from the file. All right. Output or output mode. Each time it hit this, it will delete the file and then recreate it and allow you to add the data. Trunk, okay, this will allow you to, if it exists, okay, it will still delete the information and then what? Create a new file and put the data in it. So these work similar, but they're a little different. All right. So it says several flags may be used together, okay, if they are connected with and this is the pipe symbol, class. See this right here? If you look on your keyboard and you look right above the enter key, and where you see the backslash, and they got that little line, some of the lines may be divided, that straight line up and down, that's like the pipe symbol, all right? And what happens is you can use that to what? To give 2 different flags to a file, okay? So look at this. So they're using the pipe symbol here, that operator. So it's like data file dot open, and then what's the file name? In double quotes, in parentheses, info.txt, then iOS in, then the pipe symbol, iOS.out. So look at it. This statement open the file info text in both input and output mode. This means that data may be written to and read from the file. Now, look at what they know. When used by itself, the iOS out flag will what? Cause that file to be deleted, and then what? Recreate the file. All right. Okay. When used with the iOS in flag, however, the file existing content is preserved. So it's almost like using what? A pen, right? So the content is preserved. If the file does not already exist, it will be created. All right. So that's what happens. You can, like I say, you can use them together. Now look at the next one. The following statement opens the file in such a way that the data will only be written to the end to its end. So what happens? I open the file for output, but then I append it where? At the bottom. So now what? Now the file is opened, and now what? I can add as I write to it. I'm adding lines to the bottom of it as I write, whatever I'm writing. Okay. By using different combinations of access flags, you can open files in many possible modes. All right. So this is just a simple program where you actually not even declare, you just outputted information to, and I said output because what this says, iOS out. So I just looked at the program and looked at the object of the open file and to see what it is for. So look, you got your shell, int main, open curly brace, close curly brace. But then what? We got F stream. You got to have your F stream library loaded. All right, you got to have it loaded. Then you got what? F stream. Is it input? Is it output? We don't know at this time, right? But it's going to be a file object. It's called data file. But then what happens? We say data file dot open. Now we look here, it's open for output. So somewhere on that system, you're going to create, right? Because what? Out says what? Even if the file exists, we're going to delete it and we're going to create it again. So it's going to create that file called demo file.txt, and what? Anywhere I have data file and streaming to it, it's going to write Jones, new line, Smith, new line, Willis, new line, Davis, new line, and then I'm closing it, and then I'm C out. Where's the C out information goes? Where that information go? It's going to print out done, new line. Where that go? Where are you going to see that at?
In the command window.
Right, on the screen. Remember, on the console. C out stands for console out. So anytime I have this file object, I know I'm writing to what? To that file. But when I see C out, I'm writing to the screen. All right? Because if I gave you a program to write, to say, allow a person to input a cost and a quantity, but then I want you to write the total cost to a file, okay? You would have to do a what? C out, please, and a cost. And then C in cost. C out, please, and a quantity. And then C in quantity. But then you would have to do what? I'll say total is equal to cost time quantity. And then I would do what? Data file, what? Total. You understand? Because I don't want to see it on the screen. I want it to go where? To the file. Everybody understand that? The C outs allowed me as the user to be guided as to what I input. But then when I got my input, I calculated my results, and then I just what? Wrote it to the data file. Everybody understand how that works? All right? Okay. So in a sense, we see the data as Jones, and then on the next line, Smith, on the next line, Willis, on the next line, Davis. but actuality, the information is kind of written in sequence on a disk, all right? Because one file, if just like with our Word document, a Word document has a starting point, all right? The beginning of the file, and then it have an end of file, so the system can know where to stop reading. How many? And I think I asked this before. How many people have ever had experience where they was working on a document and say it wasn't auto-saved or anything, and you were saving it, and the power went out, and your computer went out, and then you cut the computer back on, and you tried to access the file, and you had problems reading the file, and it says cannot encounter in the file. That's because while the file was being written to the disk, it never got a chance to completely writing everything and giving that in the file marker. So all of a sudden now you got a file that's lingering out there because the system cannot read it. The system cannot read it and say, now I didn't read the end of the file. This is the file. All right. So that's what this here. Every file will have an end of file marker on it. All right. And if not, it can't read it. All right. It just cannot read. All right. So it tells us the /n we know, which is a new line character. And we see that it's only /n is one character, just like the the zero null terminator was one character, right? So it's one character. // is what? One character. It's just the /, right? The system sees two, but we know it's only one. Now, the /n character is written at the end of it's written to the file along with all the other characters. It has to be, because the system will not know what to go to a new line and start writing. All right. So you have to, and those characters, how many people have ever used, and this back in the day, some application called WordPerfect? WordPerfect was a word processing application that came out when Word came out. And WordPerfect, what it did was it allowed you to go and see reveal codes. Now, what are reveal codes? Say, looking at this, we could see these characters, and if we typed it in Notepad, these will all be the same font size, same spacing for every character, etc. But when we have Word and we have that software I told you, WordPerfect, what happens is when I highlighted this and I chose bold, then you would see bold at the beginning and then in bold. And if I underline it, then you would see underline, then in underline. So and those were reveal characters so that you can see what actually was done to those characters. All right, because that's how the printer will print it. It say, okay, bold, okay, change it to bold. Okay, underline, okay, I need to underline. And then what? Right, and then it could have either a font size. So if I highlight that and change the font size to 10 or 18, then it'll have the name of the font and the size, 18. And then, so those were reveal characters. They were non-printable, but it controlled how the data was to be printed. All right. So, but you're looking at this, normally just put data in a file, a flat file, a text file, and it's just each character, same size, same whatever. And these new line, the new line character, and you'd see them all in a row. Now it doesn't have to stop at the L here. It could be going on and on and on and on and on, and then eventually wrap or whatever. But those characters have to be in there so the system will know how to give that data back to you exactly as you have it on the screen when you actually run your program. All right. So the characters are added in the file sequentially. Sequentially mean what? In a row. I wouldn't say in a row. In a line, one after the other, sequence, in sequence, one after the other, one after the other. So that is say, okay, I'm gonna print JONES, new line, Next line, I'll start off SMITH. Oh, new line. Then I'll start off WILLIS. Oh, new line. Then DAVIS. Oh, new line. And then, oh, in the file, hey, I'm finished printing. So that's how the system would actually look at that. Okay. So the very last character is an end of file marker. And that end of file, like I say, remember when we did the reading from a file, like a data file, we read a name, then we read the next name, and we could do what? While not in the file, because all files should have a in the file marker to know what? When you're at the end. All right. So it's automatically written to the end. If not, you're going to have issues. Okay. The particular mark used depends on the operating system. So it just depends. But when you write the code, it knows what that end of file is. All right. So just like the new line character, the end of file marker is a non-printable character also. Okay. Any questions? Anybody have any questions? All right, so let's look at this. Let's look at this program. This program will write data to a file, close the file, then reopen the file, all right, and append more data. So what? This example just showing you how what? Rather than write Jones, Smith, Willis, and Davis to a file and finish, I can open the file for output, all right? Look here, data file.open, demo file.txt, and it's open as output. And so we outputting Jones and then a new line. We outputting Smith and then a new line. But we did what? We closed the file. Now, unlike, how would I say it? Well, no, the same thing. But if we would have just said data file.open, demo file, and use only the out flag, anybody could tell me what would happen? If we just use the out flag without the APP, the append flag, what would happen?
It would open the file, but it wouldn't write anything to it.
But no, and it'll go on and execute this though. What would happen? Without the APP, what just this? If I just had the out, what would happen?
It would delete the original one?
Right. It's going to delete the file that has Jones and Smith, right? Demo file .txt has Jones and Smith. It deletes that one and reopen another file named what? Demo file.txt. And what's going to be in it?
Nothing, because
after it run this, what's going to be in it?
Willis and Davis.
Correct. So you see what happens without putting that APP on it. I would write to that file Jones and Smith, but then I'll come up here, I'll close it, reopen it, and it'll only write Willis and Davis. And when you open the file, it's like, where's my other two names? You got what I'm saying? But with that APP at the end, it says, okay, I'll create the file. I'm gonna write Jones and Smith. All right. Then I'll go up here. I'm going to open it again for output, but this time I'm going to open it and append it. And whatever I write to that data file object, I'm going to just add it to the end. So now you'll get what? All four names. Everybody see that? Questions? Questions? Everybody understand what happened?
Yes, sir.
All right. So that's what I'm saying. You gotta watch it. It's tricky. So it says what? The first time the file is open, two names is written, Jones and Smith, and then you gotta end the file marker. But then the file is closed. So, cause what? You close the file. Cause if I tried to do this without closing the file, I got a violation, right? Why would I open a file and then try to reopen it when it's already open? So what? They open the file. They closed the file, then they reopened it as output and append, which allows you to add to the end. You write to it, and then you close it again. So it actually writes Jones and Smith, and then it closes it with the close, right? So it adds the end of file. Until you write the close, let me see. Most systems defaulted. but when you close it, that's when it adds the end of file. But normally it is defaulted. Like if you don't put close, it'll automatically add it because the file has ended. But when you do the close, you know that what? I'll put my end of file marker at this point. So now, well, as whatever been written. So when the file is reopened, the new output is appended, not deleted, because we added what? The APP along with the OUT. All right. So it's going to have Jones and Smith, and then it's going to just append Willis, new line, Davis, new line, and then, close it. In the file marker. Okay. So if the iOS out flag had been alone, like we was talking about, without the APP, the iOS APP, the second time the file is open, the file's content would be deleted and only Willis and Davis would be the content of the file. So it just repeating what we just said earlier. You have to reopen it as a pin if you want to add to it rather than destroy it and start it again. All right. So we've used these, right? We've used these data type or the file types. So the IF stream and OF stream file data types each have a default mode, which we know what? IF stream input, OF stream output. This mode determines the operation that may be performed on the file and what happens if the file if the file that is being opened already exists. Now, so we know OF stream, this file is open for output only, right? So data will be written to that file. And what? If the file exists, it will be deleted and then have a new file. IF stream, all right? This is open for this file is open for input only, all right? Data is read from the file, but is not written to it, okay? The file contents will be read from the beginning of beginning. So you start where? When it's open, the point is at the beginning and you read as you read or read across as you read, it'll read the data. If the file does not exist, then you get an error, it fails, all right? Now, you cannot change the fact that IF stream may only read, all right, from, and OF stream files may only be written to. Now, but you can vary the way operations be carried out on these files. So what is this saying? It's saying that I can have a file object defined as OF stream, but I can use what? A pin, in that OF stream because I know what? I can use a pin for output, all right? So I can't force this to be some for input because I said this file object is for output. But I know what? I can use out for output object and I can use a pin for output object, all right? So that's all it's saying. So, so it says you can vary the way operations are carried out on these files by providing a file flag as an optional second argument to the open function. All right. So what happens here? Before, when we had OF stream out file and we had out file dot open name of the file, and we stopped here, that file would what? Be automatically wiped out and recreated every time we open, every time it did an open. But now we know it's open for output, but now it's open for output right here. And then now we want to what? Append it. So it's open for output and now it's appended. So the file is not deleted. It's going to be what? Added to. So you can still use your OF stream and know that the file can only be used for output and then set those flags to do the things you have to do. All right. So the iOS flag APP, which stands for pin, the flag specifies that data written to the values.txt file should be appended to its existing content. All right, so that's all it says. Now, and we know, and this is example 2 to check to see what if a file exists. Just a small example. This example can how would I say, can remove a lot of headache when you're writing code and you're dealing with files, and it's like, well, why my program not running? Why is this not doing whatever? Simply putting something like this in can prompt you to tell you, oh, file already exists, or the file doesn't exist, or whatever. So if sometimes you may want to determine whether or not a file exists before opening it for output, and even the way you want to open it. Because what if I use this open here, like data file.open values.txt, and then iOS out? That means I'm going to wipe away the original value.txt and then create it. All right. And then in this one, it says, okay, the file already exists, just close it. So it's not open. All right. So look, wait a minute. Okay, so if the file does not exist, all right, the open operation will fail. So you don't want to do it. In that case, you can create something in this fashion. So you got an object, data file, okay? It's not input or output. It's a file object. Okay, data file.open values.txt, and you open it for input. Now, so you saying at this point, before we get to the if, that I'm going to be reading from a file called values.txt. That's what you're saying. I created the object called data file, and I'm opening it as input. So here it says, if data file dot fail, open parentheses, close parentheses, and then it's all enclosed in parentheses. If it fails, all right, then we want to open it. Everybody see that? All right. But what it's doing is open it for what? Output. All right. It's opening here as output, and then continue the process, and then you're going on. Now, here it tells you where what is going. If it already exists, you're gonna close it, and then you're gonna what? You're gonna say the file whatever already exists. All right. So here you open it for input, but then you check to see if it does not exist. All right. If it exists, if it does, you're saying the file exists, and then they open it for output, which means later on in the program they can write out what's in the content that's in it. Otherwise, here they're saying that the file already exists. They're closing it, and the file already exists. All right. So that's just to check to see, because if you open a file that doesn't exist, you'll get an error. All right. Opening a file with fstream object. All right. Definition statement. All right. So we have seen it already. All right. But let's look at it again. Because look what this is doing. This is opening for what? Input and what? Output. So the alternative for using an open member function is to use the file stream object definition statement to open the file. Fstream data file name.txt, you're opening it for input, you're opening it for output. This statement defines an fstream object named what? Data file, and uses it to open the file names.txt. The file is open in both input and output mode. This technique eliminates the need to call the open function. All right. So if you do this, what? You don't have to say what? Data file.open names.txt. All right. We've just did the fstream, and then we do names.txt, and we did input and output. So it's open. You don't need to use it. You don't need to do the open. All right. So it eliminates that. And when you know the name and access mode of the file that at the time of the object, that the object is defined. All right. And here's another example. ifstream input file, and this is the name of the input file. OFstream This is the output file. I mean, the object, and this is the output file. But then we did what? OF stream data file, and we have customer as input, output and a pin. All right. So these are some examples. All right. So you use the IF stream and you use the actual name in here. All right. So this is for what? Input. This is for output. And this one you don't need to open because it's got, yeah, you would do. It is open for output, but then a pin. All right. So to test for errors after you have opened a file, okay, you can use the following, okay, not input file. An input file here is the what? File object. So IF stream input file. So you open sales.data as a input, a file for input. But then now you want to check to see if that file exists. It's checking to see if it exists. And it say, if not input file, then you could output error opening sales.txt. Meaning what? The file can be somewhere on your disk. It could be on your jump drive. It could be in the application, but the application itself, wherever you directing it to look for that file, it's not there. Okay. So because like I say, it's not necessary. It doesn't necessarily mean that the file is not on your computer. It's just not in a location where the software or the program is looking for it. Okay. So you gotta keep that in mind. Wherever it's looking for that file, it could be looking for it in C. The default place could be C / programs, and it's looking for sales.txt. And if sales.txt is in your document folder, it's going to give you that error. All right. So you gotta be careful about that error. Like, well, Mr. Vesta, I have it on my computer and I know it's there. I looked at it and I saved it and I can see it. Yeah, but can the program see it? So that's what you're concerned about, whether or not the program is directed to that location. All right. Now, because you can add the path in the front of right here, sales.data.txt. You can add like C / document / So that means it'll go to the C drive under documents and look for that file called sales.data.txt. So you got to be aware of that. So we talked about files, and we when we create data files, we look at a lot of times we look at the extension. And a lot of times they are program-defined extensions, or we just create extensions like .dat, .txt, .bak, or whatever, But this section just shows you that most files on your computer or on any computer, they have extensions, and most of those extensions are categorized. Now, does that mean that all files with .bas are basic program files? No. All files that are .bat are Windows batch files? No. All files that end in .doc are Microsoft Word documents? No. But normally, these files with those extensions are associated with those applications, all right? Because I could create a file in Word that says install .html or .exe, but that doesn't say it's not a Word document, all right? Or make it an executable document, all right? So .bas is for basic programs. .bat, that's Windows batch files. And if you've ever been worked with the operating system, you'll know what type files those are. .doc, normally these are doc files, and most times on your system, the Windows, Microsoft will look at them as Word documents. .exe are executable files. .html or hypertext markup language, which is web code language files. .jva are normally Java applet files. All right, so it just gives you a different variety. .jpg, many of you are associated with those. If you take pictures with your phone or camera or whatever, .jpg or image or JPEG image files, .job, .obj are object files. Normally you create object files when you compiling something. .pdf, we all are familiar with PDF files, PDF or Adobe portable document format files. .prj, Borland C++ project files. And like I say, this is just an example of a few. .sys are system files. .txt are normally regular text files. All right. So those are extensions. And when you create your files, like say here, ifstream input file, you don't have to put an extension, right? So that means that it's just the file name. But you put an extension, then that's part of the file name. Now, I forgot up until what year, but I think once Windows, I think after Windows 7, during that time, file names on the Windows side was able to have extensions that was longer than three characters. Because when Windows first came out, they was running like under DOS. And DOS, by default, their extension was only 3 characters. All right. Anything more than that, you had issues. So, but as Windows evolved, even the file naming scheme kind of evolved. You were able to have extensions like with the HTML, which is 4, the JVA, Java, which is applet, which is 4. So then you was able to have longer extensions. All right. But like I say, that's just a little note. Now, file output. All right. It says the set precision, the fixed manipulator may be called to establish numbers and digits of precisions that floating point values are rounded to. And what it is if I'm outputting to a file and I do my set precision and all that, my number will be outputted. Like say when I do, here you got data file set precision 2. Then it's got, it tells you that it's setting the decimal place to 2. So when I output this number, all right, and if it's a float number, let's see, yeah, it's a double, it will output that number with those 2 decimal places in that data file. Just like when you write to the screen, it will do the exact same thing to the data file. All right. So here, where it got data file fixed, that's just like saying data file fixed, stream number in line. All right. So that's all that's saying. They just broke up this output stream in the 2 statements. But if I was using C out, this would be what? C out fixed, C out new line. So not new line, num. So it would output that number with them 2 decimal places, all right, on the screen. But being that we're using the file object, it's going to output that number with 2 decimal places to what? To that file. So that's all it's showing you here. You just like you write a number in a certain format on your screen, it can be also sent to that output file. All right. So that what? As you see your data aligned on your output screen, if you ran the program where you wrote it to that output file, it'll be aligned in that same fashion. All right, in that same fashion. Set W, it would be the same way. You can use it to format your output. All right. So it's just telling you how you can use it. So see how you got your table.txt is written to an out. Flag is out. But then what happens? Set W8, all right? So what it did 1, 2, 3, 4, 5, 6, 7, 8, and then write out the number. It should have had right somewhere in there. No, by default, it's to the right. So now it's going to write out this number. So it wrote out the first number, 2897, all right? When it went through the loop again, all right, to the right, and then you wrote out the next number. Well, which number? Where we're at. Okay, you wrote out the first number, all right, and then it was 8. Then you went back up a number. Oh, it's doing column row. So okay, right. It's 2-dimensional. All right, 3 by 3. So 1, 2, 3, 1, 2, 3. So the second one was what? Okay, 8. Where we at? See out here, 8. Where's the other one? I'm trying to find the other one for the output. Because where's the for loop? Column. Okay, here we go. Column, row. So everything is 8. So you got 1, 2, 3, 4, 5, 6, 7, 8. So the next number, this is 0 sub 0, 0 sub 0, 0 sub 1. All right. So I'm still on the what? 0 row, first column. So 5 is printed in the 8th spot. Then 1, 2, 3, 4, 5, 6, 7, 8. Then it printed out 837. But then what? It kicks out the loop and print a new line. All right. Then it's gonna output the next number in the eight positions. The next number 8 positions. The next number 8 positions. So that's in here. And then it kicks out of that loop for 3, and then it inline. That's your inline. Then it print out the 390, go 8, the 334, 56, go 8, and then 12, and then it kicks out the loop, new line. After it does that, I'm finished with the row, and then what? Close the object, and then write out done to where? The screen. Done is not in this file. Done is written to the screen. All right. Okay. So, anybody with any questions? Question? Yes, sir.
No, I said not yet. Sorry.
Oh, but see, that's the chapter. All right. Now let's look at the assignment. Let's look at the assignment. So, all right. Should I give y'all 2 assignments or 1 assignment? Should I do that? All right. And this one, you're the initiator. See, because this one just gonna do the program. No, let's see. Right, it is. All right. So, yeah. Okay, write the records to an output file. The record, no, I want you to do the last one. Let's see. Using the same instructions you had. Right. I want you to do program 13. All right. That's the one I want you to do. And I'll go back in Canvas and open that one. Now, let's look at this. Let's read through this one. This is a previous program, correct?
Yes.
Right? So if you've done the program, the only thing you're doing now is writing the data where?
To an output file.
To an output file. You're already reading from an input file, but now you're writing to an output file. Now, so that's what this assignment is to do, all right? But this is what I want you to do, and let's look at it. Using the instructions in program 12, you read the data from the input file, right? But this time, I want you to create a data file that has your name, the course name, and the date on the, well, it could be the due date on the first 3 lines, all right? Name, course name, due date. You're gonna have a file. What's that file name? Whatever you call it. Well, I should give you a file name so I'll know and I'll be able to grade it easier. Make that file, and I'll put in the content. Make the file name CSCI 194.out. Okay, everybody got that? Hello? Yep. All right. I want that output file to be called CSCI 194 out. Now, I want you to write the program to open the output file called CSCI 194.out in a pin mode and write your output to this file. So what should happen once the file is completed? What should be in that file?
It should be all the data from the original one.
What else? Should have your name on one line, the course on the next line, the date on the next line, and then it should have all of the what? All of the data from the execution. Because I told you to what? Append. Where's that? Append. Right. So I told you to open the file in what? Append mode. Now, this is one of the things. You may execute the file and you may have errors. So you're gonna have that file and you're gonna have that content. You might have to delete all that content back out up until the what? To the name, right? I mean up until the date. So you have the name, the course, and the date. Then go back and execute the file. You understand what I'm saying? Because if you keep executing a file that you append and you got errors, what happens? Now you got a file that's listed with all kind of information, runtimes in it. Everybody understand that?
Yes, sir.
Everybody got that? So what I want you to do is I want you to do number 13. I don't want you to do 12 to where you just where's that? Where's that? Read the data. Each whatever where say right. The records should be written. No. Where's that? No what? I thought I said to write it to an output file here. Write the read from a data file. Each record contain whatever should be calculated. Oh yeah. Oh, okay. Write the record to an output file. See this part?
Yes, sir.
Yeah, this part should be, I would say, eliminated here because you're writing to an output file, but you're going to write to an appended output file. All right. So you're going to do this program, but you're going to do the append mode. All right. Everybody understand that?
Yes, sir.
Questions? Questions? Anybody?
Sure.
All right. So you got me. So when you complete your assignment and you look at and you open up your data file and look at it, it should have your name in the top corner, your the course name, the date, and then the execution of your program. Right? But and like I say, but you got to remember, as many times as you execute it, that's as many times as you're gonna get output written into that file. Because you're doing what? Appending it. So you may have to go back and delete everything up to the date, and then run the file. Once you get it running right, run it, and then you'll see name, course, date, and then the successful output. Correct?
Yes, sir.
All right. So now what I'm gonna do, I'm gonna post the quiz and the test, and for you to take, I'm gonna post the practice. All that's gonna be on. I'm gonna post that next week. Yeah, I'm gonna post the practice test and the makeup on the 22nd. All right, but I'll go and do that. It'll be there, but it won't open until the 22nd, and I'll post that. And that assessment, I'll post the assessment too. So make sure you take the assessment also. All right?
Yes, sir.
All right. Any questions? Questions? All right. So I'll see y'all on next class period, okay?
Yep.
All right. Have a good one.
You too, sir.
All right.